Hey guys, thanks for stopping by. Welcome. This video is a quick look at how the swing function works on the OXI One Mark II sequencer. Swing didn't behave the way I assumed it would, and the draft user manual is a little vague about how it works, so I hooked up the OXI to a MIDI monitor to see the precise timing. I think I figured out how swing works on the OXI, and I hope sharing this might be helpful for other folks. Here's the oxy with a simple 16 note pattern. I'm going to talk a lot about odd and even numbered notes in this video, so I've numbered all the notes in this pattern. Basically, swing affects the timing of the triggers for all the even numbered notes. You can see the current swing value for this sequencer track near the top left corner of the display, circled in green on this slide. You can change the swing value by holding down the Shift button and turning the second encoder knob. I've circled those in red. At the default swing value of 50, even notes trigger exactly halfway between the triggers of the adjacent odd notes. Swing values lower than 50 move the trigger of even notes earlier. Swing values above 50 move the even note triggers later. Swing does not affect the timing of odd numbered notes at all. On the OXI One, swing is set per sequencer, so you can have different swing settings for each sequencer track. I should point out that for the purposes of this video, I'll say note a lot, but I'm really talking about beat. For example, in this pattern, not all of the beats have MIDI notes assigned to them. I've circled the even notes in this pattern in red. If we change the swing value for the sequencer, it will change the timing of just those notes. The odd numbered notes, circled in blue, won't move. You can see that there are no notes in position 7 or 9 in this pattern. If I adjust the swing for this sequencer, it will move the trigger point of note 8, right, this one, relative to the trigger points of beats 7 and 9, even though there aren't notes in there playing. Okay, let's get to OXI One's swing math and see how this works in practice. This diagram shows 3 consecutive note triggers in an OXI One sequence. The first and third notes are odd numbered, and the second note in the middle, this one with the red line, is even. In a longer sequence, this diagram could describe the timing of notes 1, 2, and 3, 7, 8, and 9, or 41, 42, and 43. Basically, any 3 consecutive notes where the first one is odd numbered. The horizontal axis on this diagram shows time expressed as a percentage of the total time between the triggers for these 2 odd numbered notes, this first one and this third one. The red line in the middle represents the trigger of the even note. At the default swing value of 50, the even note will trigger exactly halfway between the neighboring odd note triggers, at the 50% point in this diagram. Changing the swing value for this sequencer track moves the even note trigger earlier or later relative to the neighboring odd note triggers. You might reasonably assume that the OXI swing values are simply the percentage of time between odd numbered notes, that if you set the swing to 10, even numbered notes would trigger 10% of the way between the odd numbered notes. Unfortunately, it's not quite that straightforward, so let's see how swing values actually map to note timing. The OXI One has a theoretical swing range between 25% of the time between odd note triggers and 75% of the time between them. That's shaded light blue on this slide. A swing value of 0 would place even note triggers 25% of the way to the next odd note trigger. A value of 100, a swing value of 100, would trigger even notes 75% of the way between odd notes. I call this the theoretical swing range because although it is the scale that the OXI uses, we can't actually move even notes the whole way to the beginning of the theoretical swing range. The firmware restricts swing values to a minimum of 10 and a maximum of 90. So here we can see the available swing range in green above the theoretical swing range in blue. These are the swing values that OXI lets us set. At the minimum swing value of 10, even note triggers will occur 30% of the way between odd note triggers. At the maximum value of 90, even note triggers will be triggered 70% of the way between odd notes. So while the theoretical swing range is between 25 and 75% of the time between odd note triggers, the range we can actually address with the OXI with swing is between 30 and 70%. So how does this translate to actual timing? It depends on the tempo. Let's look at the example of a sequencer set to 60 beats per minute. There are 500 milliseconds between consecutive odd note triggers. At the default swing value of 50, right, where the red line is now, even notes will trigger 250 milliseconds after the previous odd note trigger. At the minimum swing value of 10, even note triggers will occur 150 milliseconds after the odd notes. And as we saw on the previous slide, that's 30% of the way between odd notes. Likewise, at the maximum swing value of 90 here, even note triggers will occur 350 milliseconds after the preceding odd note, or 70% of the way to the next odd note trigger. Those numbers would be different if the tempo was different. Okay, so what if we need to calculate swing from a desired timing or the timing from a swing value? It's pretty easy using these simple formulas. For example, if we want even note triggers to occur 65% of the way between neighboring odd note triggers, we plug 65 into this first equation. 2 times 65 is 130. 130 minus 50 is 80. So a swing value of 80 places even notes 65% of the way to the next odd note. Working in the other direction, we can calculate the timing from a swing value. For example, let's look at a swing value of 40. 40 divided by 2 is 20, plus 25 is 45. So a swing value of 40 places even note triggers 45% of the way between neighboring odd note triggers. Okay, so swing affects the timing of even notes. Swing does not affect the timing of odd notes. At the default swing value of 50, no swing, even notes trigger exactly halfway between the triggers of the adjacent odd notes. Swing on the OXI One can move even notes as early as 30% of the time between the preceding and following odd notes. Swing can move even notes as late as 70% of the time between preceding and following odd notes. That's swing set to a max value of 90. That's basically it. I hope that's useful. For the outro, let's see swing in action. Thanks for watching, and see you again soon.